I'm going to be weighing this benzyl into a container though. The container I'm going to use is a centrifuge tube. For small scale extraction, centrifuge tubes are nice to use for the extraction. That's what I had in the diagram for the intro to this. It was kind of a shorter centrifuge tube. So we're going to use this. So since we're going to use a centrifuge tube, I want to make sure it doesn't leak. What I'll do initially is I'll kind of just lightly run my finger across the top and feel for chips or little cracks in it. And I don't. It feels pretty good. And I also want to make sure the cap is good. Inside of the cap, it should have a Teflon disc. See how that, probably hard for you guys to see. See how it's a little discolored, like gray? If you're live, you'd be able to see that that is a Teflon disc in there. Maybe you can just see it now. That's going to help seal it. But still, sometimes you cap these and you think everything's good. It feels like a good seal. But when you have an organic and an aqueous layer, 2 layers, and you shake it, it'll leak. So I'm going to try to test to see that it doesn't leak. I just went ahead and added a little tap water. So I'm going to cap this and then just start slow, give it a little tilt. Yeah, it looks pretty good. It's not leaking at all. So that's good. This is ready to go. I like it. I'll use this one. I'm going to label this MFS, put the date, 3/16. 2021, and then we're going to add to this benzyl and benzocaine, benzocaine and methylene chloride. All right, so I'm shooting for about 50 milligrams. Let me turn on the scale first, and I'll bring the camera closer so you can see what I'm getting there. This actually, if I put this piece of paper on here right now, it's not going to be good. I'll show you why. So the scale is right here. That's what we need to put things on to get the mass of. This is not the scale. So if my paper is resting on that outer rim, that'd be bad. So maybe I'll just cheat it. I'll go like this. There we go. So I can measure it like that. And then I'll go ahead and tare that. Looking pretty good. Now I'm going to set you down and get some of the solid out. So should I add my benzyl just straight onto the piece of paper while it's in here? Like maybe through the top, just do a quick like 3-pointer. No. What about just like from the side, like kind of just toss some up like that and hope it hits? No. I want to always take whatever I'm putting my material on out of the scale and measure it out of the scale. This way, if I spill a little bit, it's on the counter, super easy to clean up. It's not in the scale. So I got a little bit to start here. Let's see what that looks like. Ooh, I went over a little bit. So 50 milligrams would be 0.05, and I'm at about 0.0799. So I'll take a little bit back. So should I put it back in the reagent bottle? I think it's okay because this piece of paper is clean, my spatula is clean. I don't like to waste chemicals. Boom, I'm gonna pull a little bit back, put it in the scale. Let's see what we get. Oh, it looks pretty good. I got 0.0513, 514. I'll go with that. Now this amount of benzyl, I'm gonna put that in my centrifuge tube. And since it's on a nice crease here, I should be able to do it. Get a good transfer. Yeah, that worked out pretty good. So I've got a little bit of benzyl in there. Okay, next up is the ethyl 4-aminobenzoate, otherwise known as benzocaine. So I'm gonna do this not on the exact same piece of paper because I have maybe some dust of benzyl on this, and if I add too much, I don't want to add that back into my reagent bottle. So what I'll do is I'll just grab another piece of scratch paper. Be right back. You can also use whey paper for this, but scratch paper is fine. Alpha 4 amino benzoate, aka benzocaine from Oragel and things like that. I'm going to take my paper out of the scale to add it, just in case I spill a little bit. Put it back in the scale, see what we get. Actually, you know what? I'm going to add a pinch more. Never mind. Okay, now I'm at 0.0591, 585. Okay, I'm going to go with this. That scale's kind of all over the place right now. Not too bad, but close enough. So I'll look back and tell you what it says right now. It says 59.0 milligrams. All right, and then I need to add that to the centrifuge tube. And here's what it looks like. Got it. Oh, yep, got it. There we go. All right. So I've got benzocaine and benzyl in here. And now I've made a mixture of the two. I want to separate them. How am I going to separate them? With extraction lab techniques. First, I'll add some methylene chloride to this. This is my benzocaine. Then I'll start drawing it out, and we're going to look at the structures, and you're going to say, do this, do that. So I've got some methylene chloride here. Remember, methylene chlorides are dense organic solvent, non-flammable, which is weird. And it's going to usually be on the bottom layer. I've never seen it go on a top layer because of the density. I'll grab a graduated cylinder. The volumes that we use in these type of experiments, they aren't all that important. They're approximate is what I mean. They're important, but they're not, you don't have to be super precise with them because we're doing everything generally in excess. So I'm going to first drop some methylene chloride and see how it's dripping. Am I on video? Yeah. But if I push that out and drop some more, it's going to evaporatively cool the inside of the pipette. Okay, I'm hoping that when I add this methylene chloride to my centrifuge tube, it'll dissolve both solids completely. I'm going to use the separatory funnel again. And I'm going to hold it in a way, I'm not going to set it like that because then it can have like a problem with gas not being able to escape. I'm just going to hold my fingers like this so it can more easily let gas out. All right, so I got about 4 milliliters. And is it looking like it's dissolving? It's looking pretty good to me. There's some stuck on the top, but everything down below is dissolved. I think this is working good. So I'll cap it. And I'm going to invert it, like kind of shake it up so we can get all that. But I'm going to be careful because I checked this for leaks with water, but sometimes the organic solvents will leak even though the water wouldn't leak because they're a little thinner. But it's looking like it's pretty good. Yeah, I like it. Show you the extraction diagram. It's got an ester on one end of a benzene ring, an ethyl ester. And then the other end, it has an amine, but really we call it an amine, but it's an aniline because when you have the nitrogen attached directly to the ring, it's not as basic. It actually resonates into the ring, changes it a little bit. So that's benzocaine. And we also have benzyl. The benzyl, remember, is the diketone with 2 benzene rings. Okay, there's our benzyl and methylene chloride. They're both dissolved in the methylene chloride organic layer well. What can I do now, extraction-wise, to separate the two? What can I add? I want to add some sort of aqueous solution that's going to help separate them. And I'm going to say this side's my aqueous, this side's my organic. And I'm going to add about 4 milliliters of 1.0 molar HCl aqueous. So what is that 1 molar HCl mostly? Yeah, it's almost all water. That's what's going to create our aqueous solvent. And then what else does it have besides water? We're gonna have mostly water over here, chloride and hydronium. And you said the benzocaine will react. What will it look like over here? Protonated amine, NH3 plus. So it's gonna have that positive charge, and that's gonna make it water soluble. Okay, so do you think the benzyl will react with the hydronium? It won't, huh? So is it gonna go stay in the organic layer, do you think? So the benzyl will come over here into the organic layer with the methylene chloride. And this one's kind of nice because we know benzyl's yellow, huh? So we can watch color-wise when we do this. So we have methylene chloride, benzyl. We might have some unreacted benzocaine too. We don't know yet. So I'll just leave space for that. But I know for sure, I'm not know for sure, but I'm pretty confident. Benzyl will be here, methylene chloride will be there. What else should I put in this box? Put a little bit of water in there. Okay, and we could have some unreacted benzocaine there. We'll see. So let's do it. So I've got my 1 molar HCl here, which is mostly water, even though the label just really focuses on the HCl, which there's almost none of. And I'm going to do about the same volume, about 4 milliliters. Okay, so I'm going to add the 1 molar HCl. I'm holding this so that I'm holding it a little above. I'll hold it this way, right-handed. So I'm going to let some air out as this goes in. All right, I got that in there. It definitely looks like 2 layers for sure, huh? It's only a reaction occurring between the 2 phases, the organic and the aqueous. It's only interacting right at the surface, you know. There's actually a little organic sitting on top of the water, the water's surface tension. But so there's not really great reaction conditions now. What can I do to help this reaction take place, help the amine get protonated? Yep. And when you shake it up, you got to be careful at first because usually it's an exothermic reaction. It can build up pressure. So if I just cap this tight and shook it a bunch, and then when I first open it, it might kind of vent on me hard. So I want to cap it good. And my first little shake, I just kind of do a tilt. And then I like to tap the cap to make sure nothing's stuck up there. And then I'll vent it. Let's see if we can hear anything. I don't know if you heard it, but I heard just a little bit of a vent. So I'll do that again. And I didn't even hear a vent that time. So I think it's good now. It's kind of gotten through the beginning part. So I'll give it more of a shake. Vent. Yeah, I'm not getting any venting. So I can really give it a good shake now. And you'll see after I shake it, it'll slowly start to separate out. Do you see that? Pretty cool, huh? The more dense methylene chloride is sinking to the bottom. I can do this some more. Nice separation. One thing that's nice about doing this small scale extractions in centrifuge tubes is if you have trouble with this separation, sometimes you get what's called an emulsion, where you'll get like 1 layer on the bottom, then kind of a cloudy mix, and then a layer on top. What you can do is you can put this in our centrifuge and it spins it, and it makes the more dense layer sink to the bottom more. Okay, but this one's separating out well. So we're looking good. I've got the 2 layers. They're pretty well separated. Sometimes I kind of tap at it. And what do you think I want to do? Do I want to remove the lower layer by putting a pipette through the top layer and sucking it out? Or do I want to try to remove the top layer? Narrower at the bottom, it's easier to separate that way. So I just got to grab a pipette bulb and I'll demonstrate. So, and also I'm going to put this lower layer into a test tube. So I'm going to label it. I'm going to give my initials, date. I'm going to say first lower layer. And I'm going to say it's methylene chloride. I'm like 99.99% sure it's methylene chloride, but I could make a mistake. So I always like to check it, and I'll show you how I check it. But first, let's get it. Oh, I'm going to do something else too. Here's a nice pro tip. I don't know if you can see it on your end, but there's a little bit of organic layer on the upper part of the water there. So if I try to suck along the top of the upper aqueous layer, and then I deposit it at the interface, that organic will then kind of associate with the lower organic layer. Okay, here we go. So I'm going to, I'm going to stick my pipette through the aqueous layer. And what I like to do is kind of push the bulb and give it a little pressure so it won't grab any of the aqueous layer. And then I go down to the bottom, maybe let some out, nice drop some of the lower aqueous layer. And then when I'm coming out of the aqueous layer, I kind of go quickly so I can not pick up any. When I'm coming out of the organic layer, I go kind of quickly to try not to get into the aqueous. So let me try to do that again. It's looking pretty good. And see how the organic layer now is getting narrow on the bottom? It's going to be easier to separate these two because of the narrowness of the centrifuge tube. Now this part, I got to be careful. I just got to do my best. It's not going to be a perfect thing.
You can't really see the bottom end of the centrifuge.
Sorry. Oh, I blew it. I'll do it again in the next extraction. So I did remove the lower organic layer completely, and it was getting narrow at the bottom. Sorry about that, but I'll do it again. Okay, so this should be my upper organic layer, right? I'm going to put this aqueous layer in a side test tube here. This will be my first aqueous layer, and this is going to be, I believe this should be the ammonium, huh? This is my aqueous layer, and that's what I predict is in there, right? And this is my organic layer. Is there something that's suggesting it's going well to you? Benzyl's yellow. Looks like it's in the yellow organic layer. And this is white. When it dissolves, it's just clear, the benz. But I want to do something that I always want you to do, and I need a water bottle to do it. I'm going to put DI water in the water bottle. I'll use this to test to make sure this is the aqueous layer. If this is the aqueous layer, when I add the DI water, should it create 2 layers or dissolve? Yeah. I added a squirt, it dissolved. Looks good. If I put the water in this organic layer, it'll form 2 layers, huh? I can actually do it because it won't matter for the next part of the experiment. I'll show you. So let me put a squirt. I didn't put quite enough. Let me do a little more. Do you see how I've got a separate layer on top? Yeah. So this is definitely my organic. This is definitely my aqueous. What you should do whenever you do an extraction, and every time you separate an organic and an aqueous, you're usually pretty confident. Oh yeah, this is the aqueous. Just shoot a little water in the aqueous to make sure. And I normally wouldn't shoot it in the organic because I just want the organic to be organic, but I know I'm going to extract this with another 1 molar HCl, so it's okay. So I've got my aqueous now, and I know it's aqueous. I think the ammonium's in there. What can I do to prove that it's in there? I want to prove that the amine that was in the original flask came over here as an ammonium. I want to prove that. How can I prove it? Yes. I'm going to make this basic. I'm going to change this aqueous layer from acidic to basic. So I'm going to add, what kind of NaOH should I add? Should I go 1 molar, 6 molar? What do you think? Go 6 molar NaOH. Because I don't want to have to add a lot of water. I'm not even going to do 4 milliliters. It's going to be more like, it's going to be less than 1 milliliter because it's 6 molar. I have to quench the 4 milliliters of 1 molar HCl. So I'll need, since it's 6 molar, I'll just need about, I don't know, 0.7 milliliters or so. You can, yep. I was saying that whenever we start an extraction, start with 1 molars because it's not too concentrated. It won't cause any problems. 6 molar NaOH could maybe start to slowly hydrolyze that, react with it. But 1 molar won't, and 1 molar HCl won't. But now the 6 molar, it sounds like, oh, it's going to be harsh, but it won't because I'm going to be adding it slowly and it's going to constantly get quenched by the hydronium. So we're gonna go 6 molar. I've got it here. And with the 6 molar, that's getting a little bit concentrated. It's not too bad. You could put on gloves at this point, but I think I feel safe and calm with it. If I do get some on my hands, I just wash my hands right away. And as I'm washing my hands, they feel slippery because it turns the oils in your hands to soap. So it feels like you have to keep rinsing your hands because your hands, the oils are turning into soap, turning yourself into soap. Okay, so what I want to do then is I want to slowly add the 6 molar NaOH to my acidic, what I think is the ammonium. And what is that 6 molar NaOH made up of both mostly? Mostly water still. It's like 50 molar water and 6 molar sodium, 6 molar hydroxide, right? So we're still adding mostly water. Is there going to be a reaction? Yes, there will be a reaction because the ammonium reacts with hydroxide, gets deprotonated. Before I do it though, I'm going to do something. This solution should be acidic, correct? This one? Let's double check. Let's make sure. How do I check the pH of a solution? Yes. Should I just tear off a big long strip and dip it in there? I'll just tear off a tiny little bit at the end. Stick that on a piece of a paper towel. And then I will take a spatula. Oh no, here on that side, it's reversed my view. All right, and then I'm gonna take my spatula and I'm gonna put it, I don't wanna just tip the top of this, barely touch the solution. I wanna really put it in there, swirl it around, make sure it's completely saturated with whatever solution this is. Okay, and then I'll touch it to the pH paper, and if it's acidic, what color should it be? Yep, it was evaporating. I think a little faster, there we go. Oh. There we go, it's acidic. Pink, right? Good. So I'll put that on my notes here. pH paper pink. That's about a pH of about 2. Okay. All right, now I'm gonna do the fun part. I'm gonna add the 6 molar NaOH and see what happens. I'll put my first drop in here and watch. This is pretty cool. Oh, it's working its way down the side. I'll do another one. Do you see that? I'm not sure if you're getting a good enough view of it. Okay, here it is. So I can't believe I'm doing this above my computer keyboard. So I'm gonna do another drop. See what happened there? What's going on? Anybody have a guess? So as the concentrated hydroxide or 6 molar hydroxide is coming through, it creates a little local environment of like a basic solution. And all of the ammonium gets deprotonated there and it becomes now no charged organic and precipitates. But then there's like excess hydronium that rushes in and reprotonates it again, makes it soluble again. So do you think I've gone to the point where I've taken the solution that was acidic, it was pink. Do you think it's now basic yet? It's not. Not just yet, we gotta keep going. Ooh, the precipitate's not going away now, huh? Well, maybe it is, maybe it is. I'm getting close. I'm basically doing a titration. I'm making this acidic solution, bringing it towards the midpoint, and then past the midpoint to the endpoint. Let's see if we get a, go past the equivalence point, and oh, look at that. It's almost all white solid now, huh? What's that white stuff? That white stuff is benzocaine. We deprotonated the ammonium. Made this. Now this, not very water soluble, precipitates out. There's no organic layer for this to dissolve in. We're over here on the aqueous side. The organic layer is off, over here. methylene chloride's over here. Okay, so do you think I've added enough? Do you think it's basic? It might be, but you know what? You should always, always, always check the pH, because we may not quite be basic. We might not be all the way basic, and if we aren't, then we're not going to get a good yield of precipitate. So I'm going to check it. I'm going to put another piece of a little strip of pH paper on a piece of paper towel. And I'm going to take my spatula, and my spatula I used before on the acidic solution. So it's got a little bit of acid on it, the spatula. So if I use it, if I just barely tap in here, I might get a bad reading. Can you guys see this? Yeah, you can see it. So if I just tap like that, I'm not going to get good reading. I want to like put it in there and swirl it around and really get it like, you know, coated with what I'm testing. Bring it over and check it. Oh, I think it's basic. Looks good. Well, it's kind of purple. Let's see. Yeah, no, that's pretty basic. I don't know, man. I got a gut instinct. I want to add a little more. Let me try. Yeah, no, I guess that's good. Okay, so this will be our first precipitate. Oh, I'll check the pH again. See if that made a different color. Yeah, that's a little darker. Okay, yeah, I think that was probably a good choice. All right, so that's our first precipitated aqueous layer. This one, if you remember, I was talking about the way to get this kind of a product out of the aqueous layer is there's two ways. You could filter it through filter paper, or you can extract it with the organic solvent, like fresh methylene chloride. When you look at this, it's pretty fine particles, huh? Do you think I would want to filter this or extract with methylene chloride? Yeah, I think if I try to filter this through filter paper, it's going to be such a fine particle. Some of it will get around the filter paper or just like caught in the filter paper. So I'm going to probably be extracting that, not filtering it. Okay, so now let me fill in my extraction diagram, see where we're at. So it looks like at this point, I did get a precipitate, and the pH was like purple, huh? Maybe pH of like 12 pH paper. Okay, so I believe I have the amine again, the NH2, not the ammonium. And because it no longer has charge and it's a pretty organic molecule, it's not going to want to be soluble in water. It's going to form that precipitate. And then I have, what is mostly in this, at this point, what molecule is most present? By far most present. Water. Okay, and what about some ions? Chloride, good. What else? Is there much hydronium left? There's almost no hydronium left. Hydroxide is what I'll put. I think of this as like, I'm just drawing my major species. So the hydronium concentration is super low when you're at a pH of 12 or around there. Okay, so that's my first precipitate. Now, I may have more of this benzoin in the organic layer, huh? How can I check for it? Yeah, do I want 1 molar or 4 molar? 1 molar or 6 molar? What do you think? You start with 1 molar HCl aqueous, which is mostly water. And then I'll put my organic layer on the right again and my aqueous on this side. And let's see what we get. My original centrifuge tube's empty, and I pulled out my organic layer to the side to test it with water, but I could put this back in. And that little bit of water in there, that's okay. It'll just dilute the 1 molar HCl that we add. Maybe it'll make it like, you know, 0.85 molar or something, which is fine, that's plenty. or maybe I'll decide to add a tad more than 4 milliliters. All right, I got that back in there. And then I'm adding the 1 molar HCl. Okay, looking good. A little more than 4 milliliters, close enough. I'll leave a gap so the air can escape as I add it. And again, it's not going to react well currently because it's only reacting at the surface. So if I cap it, I don't want to give a vigorous shake right away. I want to just give a short, I'm going to actually give it 2 of these, so maybe you guys can hear the vent. Let's see if you can hear it. Ah, it was too light. I held it next to my AirPods, but now I can give it a little more of a shake. Vent, more of a shake. Vent. Keep venting. Okay, now I feel pretty confident. It's not giving me a lot of problems with the venting. If you're doing an extraction where you have something, a reaction that takes place that creates a gas, then you have to worry about venting. Like if you're using a sodium bicarbonate to quench an acid, it creates carbon dioxide gas, then it can really vent. So you got to be careful with those. And it's separating out again, right? Kind of cool looking, huh? You can see there's droplets on the top layer that I can kind of tap at it to make them fall. There we go, not bad. Good to good. And now, am I taking off the lower layer or the bottom layer? I'll put it back in the same test tube. This is the bottom layer. Yeah. And this time I'll do a better job of showing you how it looks. So drawing off the bottom layer. See how it's getting narrow at the bottom? Okay, I think I did a decent job of separating those two. And then my aqueous layer, I'm going to put it in another test tube. Well, you know what? I'm just going to go ahead and make it acidic here. Or not acidic, basic. So it should be acidic. Let's just check. It currently should definitely be acidic. So if you guys see it. There it is, yeah. Okay, I'm getting a good sample of it. Put it on. Yeah, it's very acidic, looking good. Now I will make it basic again with the 6 molar NaOH. See how it looks. Yeah, it's starting to get cloudy, see it? Nice and cloudy again. Oh, I left a little organic in there. That was not the best. Experimental error. Oh, well. Let's check that pH as well. We've got to make sure we made it basic. Otherwise, we're going to get a bad yield of our precipitate. So I'll put my spatula in there, swirl it around, check the pH paper. Yeah, that's basic. Looking good. Okay, so we did have excess of amine in the organic layer after the first extraction, huh? So let me show you what I mean. So we did definitely had some amine here, huh? Can you guys see what I'm drawing okay? And then what do we get in the aqueous layer here? Mostly H2O, good. And then did I get, was it the amine I got or something different? Yeah. The ammonium again. And then what are the ions in this guy? Chloride, and what else? So at this point, this was our colorless clear solution that then I added 6 molar NaOH2. And when I add that, it's mostly what? Water. And does this react with the ammonium? Yeah. And that's our precipitate. This is our second precipitate. Okay, and I also have some ions. What else is in here? Sodium hydroxide and something else. All right, yeah. Okay, that was good. What about my organic layer after the second? You can call it, a lot of times chemists will call this like, oh, I did an acidic wash of the organic layer. You're washing the amine away from the organic layer. So after the second wash, what's this box mostly? What molecule is present the most? Reacted. We see the yellow color of it as well. And what else was in there? Trace of water. And I bet there's still some amine in here, but I'm not going to do a third one. I think 2 is enough. I'm just going to say probably trace amine. I know this from experience because the benzocaine you can do like 6 of these acid washes and you keep getting this milky precipitate. But I believe we've gotten like, almost all of it out already. And just for the time, I don't want to keep taking so long with you guys on this one. So we need to deal with the organic layer and the aqueous layer. Which one do you want to do first? What should I try to get rid of first? I'm not going to even get rid of the benzocaine, that little bit of trace. I'm going to leave that in there as an impurity, and I'll still be able to figure out that I have this, I think, on IR. We'll see how much of benzocaine I see in there. So I'm going to use a new centrifuge tube for this part. So this is my organic layer after 2 1 molar HCl washes. What do I do next? Yeah, it's up to us actually. Methylene chloride doesn't hold a lot of water in it, but maybe I wasn't the best at separating my layers. I see little spots of water in there, huh? Yeah, let's go ahead and do the brine wash. Brine pre-dry, sorry, the brine pre-dry. So I'll get some brine. It's over on the shelf over here. So here's our brine. It's saturated sodium chloride. You can't see it really, but I can see there's some undissolved solid sodium chloride table salt on the bottom of this. So this is saturated. Okay, so I have to get my methylene chloride into my new centrifuge tube, but before I do it, I should test it. You know how I'm going to test it this time? I'm going to test it with methylene chloride because I don't want the water in there. Well, you know what? It doesn't matter. I'm going to use brine anyways. Yeah, it's fine. So let me add a little water to test this test tube. This centrifuge, so I felt the top, it feels good. Like it's not cracked or anything. And then this cap, the little Teflon disc in there looks good. Tighten it up. Yeah, this feels good. I don't think it's gonna leak. Nice, put that down the sink, that DI water. All right, so let's add this organic layer to my new glass. Got it. If I want, let's say, oh, I want to rinse this out to get the last of that organic out. I could do that. just pipette in some methylene chloride. Give it a couple squirts. There we go. Okay, so I've got my organic layer in here, and I'm going to pre-dry it. The way I'll do that is I'll first add some brine. I will add some brine. So how much brine? I do about the same volume, about 4 milliliters. I'm just going to pour this straight through instead of pipetting it. Brine's aqueous, and it's real viscous, so it's easy to pour. Poured more than 4, but that's okay. Now I'll add that to my centrifuge tube. I might add less than the full 6. Let's see how it looks. Ah, this looks good. That's fine. I just wanted to make sure my centrifuge tube didn't get full. Got that ready to go. So the brine is on top, organics on the bottom. It might be hard for you guys to see, but let's see. Try to look at that organic layer and remember how clear it is. Is it looking real clear or just kind of clear? And sometimes when you do the brine wash, it clears up. It kind of gives you evidence that it worked. Okay, so before I start really shaking this, I want to just do a loose, like a slow tilt, and then bend. Oh, no pressure. Slow tilt, bend. Yeah, we're looking good. Okay, so now I can really shake it up. Okay, let's watch it separate out. See if it's going to do well. Usually the brine will separate better than other aqueous solutions because it's more organic. It's more polar than just water. All those sodium ions and chloride ions. This one's going a little bit slow actually though, but it will separate. If I don't vent and I shake the whole time, the first time I vent, it can really release a lot of gas and maybe spray on you a little bit. Now, to me, it looks like the organic layer got a little clearer, but I don't know if it looks as good to on your end. Does it look a little clearer? So I did the brine pre-dry. Let me write it down. This is the key to doing these two, is keeping track of everything. So I did about 6 milliliters of brine. So what's in my aqueous brine layer? Mostly. Yeah, mostly water. And what else? Yeah, and that's it pretty much. And then the organic layer, like chloride, benzyl, very trace water. Just a little bit of water because we removed the bulk of it with the brine. And then there's also going to be the trace benzocaine, which I didn't do a lot of extractions of it, but it's going to be mostly gone. Okay, yeah, it's looking pretty good now. Separated it out well. And to do the final dry, I'll grab some sodium sulfates. I like sodium sulfate because it like clumps up nice. It's easy to decant from. But people tend to use sodium sulfate for this or magnesium sulfate. Magnesium sulfate will actually grab onto more water. It'll leave your organic layer a little more dry, but you usually have to filter it through filter paper and you have to let it sit longer. It's like slower, but more effective. So sodium sulfate's good enough for me. So what I'm gonna do is I'm gonna do this in an Erlenmeyer flask. You can do it in pretty much any container, but I like to do this part in an Erlenmeyer flask. So Let's do it. So I'm going to label it up. S. Yeah. So I'm going to push through the aqueous layer, enter the organic layer, draw it up, pull it out quickly, put it in my Erlenmeyer. Can you guys see the bottom of the centrifuge tube? And then at the end, you just kind of go slow. And with experience, you get better at this kind of thing. So I'm gonna go, I may have gotten a little bit of brine in here, but I'm okay with that because I'm gonna add sodium sulfate, and that's gonna get the rest of it. That'll get out the water that came in with the brine. And the sodium chloride from the brine will precipitate out at that point. When there's no water around, sodium chloride is not soluble in organic methylene chloride. Okay, so now it's time to add our sodium sulfate. So as I'm adding the sodium sulfate, it'll start to clump as it grabs onto the water, and it'll also make the solution look clearer. I don't know if you'll be able to tell on your end, but we'll see. And also, can you see I think I could see a couple little beads of water. This guy's still got a fair amount of water in it. I could redo the brine and separate better, but it's all right. This is gonna be fine. So I'm just gonna take out some sodium sulfate and drop it in, and then swirl it around. And when I do, I can see the brine. I might even be at the point where I've added enough. Not the brine. I can see the sodium sulfate like clumps up. Can you guys see big clumps of it? That means it's hydrated. When I add sodium sulfate and it no longer makes clumps, it stays the little grains. That means I've added enough because there's not enough water to clump it up. So I'm going to do a little bit more. I think I'm already pretty close. Yeah, I could see a few. Well, I'm going to go a tad more, and then I'll call it. This comes with experience. You just kind of get the eye for it too. But normally when you're in lab, the first few extractions you do, everybody comes up, is that enough? Is that enough? And then after a while, they're like, okay, now I got it. They get comfortable with it. So yeah, I see. Really one of the main things I can see is it got much clearer, the organic layer. It looks nice and clear. And also you'll see oftentimes little beads of water stuck to the inside of the glass, and now there's no longer any water stuck to the inside of the glass. Okay, so if we wanted to get this super dry, to be really good about it, I would cover this and I would let it sit for like 15 minutes to really give the sodium sulfate time to suck up all the water. But in practice, it's usually plenty dry at this point, in my opinion. So I'm gonna just decant it now. I'm gonna decant it. What should I decant it into? Like an Erlenmeyer or a beaker? To evaporate it. Yeah, why beaker? Yep, more surface area. Yeah, so I got a nice sized beaker here. I think that's gonna work good. So let me write on it. Oh, before I decant it, what should I do with this beaker before I decant it? I'm gonna let the methylene chloride evaporate, right? Then I'm gonna have solid benzyl left over. What would be something interesting to know about it? The mass, yeah. So wouldn't it be nice to know the mass? I started with, I weighed out how much I started with. It was about 50 milligrams. So how can I get the mass of it? You got it. Let's do it. We'll go over to the scale. So I'll go ahead and zero it out. Put in the beaker. Looking about 30.845 grams. 30.0845 grams. So for the decanting, I just simply carefully pour the liquid out, and I don't want the solid to come. I want to keep that solid behind. I pour it like that, and we hold it on the edge. And I'm fine with leaving a little bit of the organic layer behind, because I'll show you what I'll do. After I decanted it once, I can take now some fresh methylene chloride that's dry and add it to my sodium sulfate to rinse more of that methylene chloride off of it. And then I can swirl it around, decant again. Maybe do one more rinse. And I can tell the sodium sulfate after the first decant was a little yellow, but now it's not so yellow. Okay, got it. Decant again. All right, so now I'm just gonna let this guy evaporate. If I just hold it here for a while, it'll start evaporating pretty quickly. The boiling point of methylene chloride is 40 degrees Celsius. And as it evaporates, this outer glass will feel it get cold because of the evaporative cooling. And that'll slow down the evaporation. So if I want it to go a little faster, I can nest it in another beaker that has some warm tap water. So I'll go ahead and do that. Let me get some warm tap water in another beaker that's just slightly larger. So I think this beaker here will be a good size. Yeah, it'll just fit in there and it won't fall over. So let me get some hot tap water. It might take a second to warm up. And then while that's in the warm tap water bath, I could hit it with the Conair 1875. You know, our Conair, the highly technical blow dryer here. I could be blow drying it to try to speed things up, but then I have to sit there and hold the blow dryer. And I don't feel like doing that. So instead, I'll just set it in the fume hood and let it evaporate on its own. And while this is evaporating, I'll go back to the aqueous layer in the from the extractions earlier. I'll get the benzocaine out. So let me get some of that warm water I was telling you about. And I'm just going to put a little bit in here. Yeah, like this. That works good. And I will bring this over to the fume hood behind the computer here. Just set it somewhere where there's a good airflow. It'll evaporate a little bit quicker in there. Okay, so back to our extraction diagram. This is key to not getting confused because there's a lot of little steps to this. It's easy to mix stuff up. So I redrew up my organic layer from the last page of my notebook, and I have the benzyl, methylene chloride mostly, very trace water because we did a brine wash, and then just trace benzocaine. I add this anhydrous sodium sulfate, and it creates a hydrate over here, hydrate, and then the organic layer here. So what's in the organic layer on the right now? Mostly methylene chloride, and the benzyl. And let's say we got rid of all the water. I'm sure there's a tad of water, but let's say it's so very, very, very trace, we'll ignore it. And there's probably still some trace benzocaine. And then over here, the hydrate, you'll have sodium sulfate. And I think maybe the most common is the hexahydrate. So it can hold on to 6 water molecules per sodium sulfate unit. Okay, so our organic layer, we're just waiting for it to evaporate. This is the, let's say, this guy. Let it evaporate. And then you have a gas over here. What's the gas that's evaporating away? Yeah, the chloride gas. And then over here, you'll have your solid yellow benzyl and the trace impurity of probably some benzocaine in there still. Okay, so we're waiting on that, and this is done in a 30.0845 gram beaker. So we'll be able to get the mass of it afterwards, and I'll also take an IR to make sure it is benzyl. Mostly benzyl. We'll probably see maybe some traces of the benzocaine. We'll see. Now back to the aqueous layer.